Good evening once again. So we're going to look at Module 4. Um, sorry. Okay, so in this module, we're going to look at these objectives. Module title, attacking what we do. Module objective, recommend measures to mitigate threats. So the following are the topic title: IP services, enterprise services, mitigating common network attacks. So we start with IP services. App vulnerabilities. What do we mean by this? Host broadcasts an app request to other hosts on the network segment to determine the MAC address of a host with a particular IP address. The host with the matching IP address in the app request sends an app reply. So what we're trying to say here is you have host. When we say host, your host can be your PC, can be your phone, that's a smart device, any other device you can think of that should be part of the network. So usually when you connect a PC to the network, it sends a broadcast, like a broadcast message. Everyone within that same network gets that broadcast message, which we refer to as app. So the app goes to everyone, everyone gets it. So assuming I want to connect to a PC, I am PC A, and I want to connect to PC B on the same network. I need to get PCB's IP address. I need to get the PCB IP address because there's no how I'll be able to send a message to PCB without getting that IP address. So what do I need to do? I need to send a message, the app message, broadcast it within that network so that the person who has that IP address will be the one to reply back with the IP address and the MAC address. That's the PCB will reply back with an IP address and a MAC address, which we call the media access control. So that's what we mean by app. The first one, you have an app request, sends the request, everyone gets it, but the one who has the IP address is the one that reply. So you have a reply, which we refer to the app reply. So you have a request, then you have a reply. So any client can send an unsolicited app reply called a gratuitous app. So when a host sends a gratuitous app, other hosts on the subnet store the MAC address and IP address contained in the gratuitous app in their app tables. So what we mean now is that aside requesting for the IP address of the other system, system B, okay, there are other things that systems would do just to know whether maybe system B is still alive or is still on the network, or the gateway. There's what we call gateway. You know, from the local area network, you want to move out of that. You want to send a data out of the network. You need to go through the gateway. It's just like, let me take, for instance, those who are within, let's say in Nigeria, you want to go outside or you want to fly out of this country, you go through a gate, and the gate can be the Murtala Airport terminal. You go through that, the Murtala Airport, to maybe you want to go to UK. So that will be your gate, okay? So the gate will have an IP address, okay, and a MAC address. So time to time, within some specific timeline, the system would want to find out if the gateway is there so that it will be able to send some information. Okay, so that is what happened. So in the process of doing so, sometimes the system can send a broadcast also to other systems, and other systems will get it. So that is not even based on like a request. It's just to find out if that guy already exists. So that forms what we refer to as gratuitous. And every system within that network get this gratuitous app. Okay. So any host can claim to be the owner of any IP or MAC address. That's the MAC they choose. Any host can claim to be the owner of any IP or MAC they choose. So threat actor can poison the app cache of devices on local network, creating a man-in-the-middle attack to redirect traffic. So since these messages are being sent, so you can see the security implication. The guy that is replying with the MAC message can claim, an attacker can claim to be or to pretend to be the gateway, or to pretend to be the PC or computer B or PC B. Okay, so that's what we mean. So the threat actor attack, I mean, the threat actor can claim such privilege. So the goal is to associate the threat actor MAC address with the IP address of the default gateway in the app cache of a host on the LAN segment. It positions the threat actor between the victim and all other systems outside the local subnet. So when a threat actor is able to poison this, poison the cache, meaning that he's able to uh, take advantage of maybe probably the MAC address of another system or IP address of another system, and whoever that is sending message thinking that is the gateway may send the message to through the threat actor, and the threat actor will be able to look at what is there. So because of this gratuitous kind of app, everyone will be able to know who sends. I mean, every system within that network will get this gratuitous app. So that is not healthy within the network. So this is the app cache poisoning. So in a system, if you look at the where my cursor is, if you can see my cursor, just say yes, just to be sure you have something. Do you have my cursor? Can you see
Yes, sir.
that? Okay.
Yes, sir.
So this is a PCA connected to a switch. The switch is connected to a router. Okay. And we have a threat actor on this end. So this PC, the PC cache has what? It has information about the gateway. It wants to go to the gateway. But in this case, what it's trying to do is that it has the IP address to go to the gateway, but it does not have the MAC address to send to the gateway. Okay, it doesn't have the MAC address because, please just take note of this. For every communication, a PC within that network will require two addresses, just like we would said in the previous class. The PC on that network will require two addresses. It will require what? The MAC address, and it will also require the IP address. It cannot make use of the MAC address alone without having the IP address. So both have to go together. Okay. So the PC has that's PCA has the IP address of the gateway. This is the gateway. So this is what the PCA has. If you look at its own address, is 192.168.10.10. Its MAC address is AAAAA all through. Okay. Then for that of the gateway, which is R1, it has an IP address 192.168.10.1, and it has an IP address, I mean a MAC address A1 all through. So this is the router. So now this PC wants to send an app request trying to get the MAC address, which is this A1, A1, A1 for the R1. He wants to get the MAC address for this. So what's he going to do? He's going to send a broadcast message to all the systems that are connected within, though we don't have other systems here, but to send to all the systems. So, but the target is this very one, R1. So it sends a broadcast app request. It goes to this R1, okay? So that is the aim. It goes to this R1. So let's look at this table here. App cache on threat actor hosts. So the threat actor, this guy, this very guy, because when you are sending an app request, in the process of sending, you will have what? A source MAC address for this very system, okay? And the destination MAC address of this in the request that is sent, the request packet that is sent. Okay, so this very guy that is seated here, who is the threat actor, just like I said, when it comes to app, everyone gets it. He equally will get that information. So the threat actor will now have 192.168.10.10 of this very system and the MAC address of this very system. And also in the process, it also gets, because at a point when this guy replies, the threat actor also gets what? 192.168.10.1 of this guy, and also gets the A1 of this very system. But look at him, he's seated here and he's having, this threat actor is making use of this. But in the process, in his case, he has all these MAC addresses. So let me show you an example how you can, let me show you how you can check your system to know if you have this cache. So let me stop the sharing. Let me use another method to share my screen. So do you have my screen now?
No, sir.
Okay, you don't? Okay, let's see. Okay, maybe what I will do, let me just take note of it. Maybe towards the end of the class, I will see if or on your system, if you have a system, you go to your command line interface and you go to a command line interface. We did that before. You go to search CMD and you type app, you put a space, that's ARP, you put a space, then you put hyphen A. You're going to see some IP address that is not related to your own system. If you also recall the way we did the other time to check the IP address of your system, is to do what you also use it within the command. You do ipconfig, you put a space /all. That will also help you to know the MAC address and IP address of your system. So, but by the time you now do that of the app, you the space -a, you're going to see a different MAC address. So whatever system you're connected to, let's say in my own case, I'm using my laptop connecting to a wired network. So the wired network there's what called DHCP. So it's giving me a reply. It's giving me a reply based on that connection. So the connection to the other end of the device, when I do the app, it's going to give me the address of the other system, including the MAC address of the other system. So you can do that. But later on, I will see how we can also use that. I will demonstrate that still. So this is how the system it was able to reply, which I've already covered in the previous slide or mentioned. So the same PCA, but I hope you can see these slides where it says app cache poisoning continuous. Hope you can see this slide.
Yes, sir.
Yes, sir.
Okay. All right. Thank you. So as you can see, this guy, the PCA, gets a reply from the R1 in the process. the threat actor is able to get all those information, the information about PCA and also the information about the R1, which is a router. So you can see this is what these guys will do. So app reply in the figure R1, update its app cache with the IP and MAC address of PCA. So R1 sends an app reply to PCA, which then updates its app cache with the IP and MAC address of R1. So spoof gratuitous app replies. We have the passive app poisoning occurs when threat actors steal confidential information. So like when this process is complete, the threat actor will probably in the why he is able to gain this is for him to gain confidential information. So that one we refer to as the passive. Then the active poisoning occurs when the threat actor modifies data in transit or inject malicious data. So the passive is to get confidential information, while the active is to inject malicious data. So let's look at DNS. The DNS attack. A DNS open resolver answers queries from clients outside of its administrative domain and is vulnerable to multiple malicious activity described in the table. So I'm going to still show you this DNS. You know, the DNS, like I mentioned before, is domain name server is a server that contains information with respect to the domain name and also its corresponding IP address for that domain. So the DNS can also be poisoned. The DNS can also be poisoned or hijacked as well. So what we mean by the open resolver, we have a global DNS server and we have a DNS server that's localized within your local network. You have those type of DNS server. So the reasons for such is like for the local one, sites that you visit often, the DNS stores such information in your local network, okay? Any site you are going to for the first time, you need to go to the open resolver, which is the main DNS server to fetch such information from. So DNS resolver vulnerabilities. DNS cache poisoning attacks. So threat actors send spoof falsified record resource information to a DNS resolver, redirecting users from legitimate sites to malicious sites. Okay, so what we mean now is if a domain name server, or a domain name is poisoned, let's say your name is Luca. Maybe the server name is luca.com. Luca.com. An attacker now poisoned luca.com. That's the name. I'm not talking about the person. The name. Poison that. So whoever that wants to go to that luca.com doesn't actually arrive at the server, but is being redirected to what? To the threat actor's server. So that's what we mean by that. So the threat actor spoof the DNS name. Okay, that's the domain name. In the process, that whoever that wants to go to the usual site will not actually hit the site. So DNS cache poisoning attacks can be used to inform the DNS resolver to use a malicious name server that is providing the RR information for malicious activities. So DNS amplification and reflection attacks, similar to what we did in our last module. In this case, threat actors use DOS, okay? DOS or DDoS attacks on DNS open resolver to increase the volume of attack and to hide the true source of an attack. So you can see what these guys are doing. They want to attack, they have a target. So in the process of attacking, they try to also hide their location, try to hide where the attack is coming from. So they use this process of DDoS to achieve that. Threat actors send DNS messages to open resolver using the IP address of the target host. These attacks are possible because the open resolver will respond to queries from anyone asking a question. So DNS resource utilization attacks. So DOS attacks consume all the available resources to negatively affect the operation of the DNS open resolver. The impact of DOS attack may require the DNS open resolver to be rebooted or services to be stopped and restarted. So like in this case, it means like when you overwhelm the system, maybe the resources like the RAM, maybe the RAM is running at 1 gig, and you now overwhelm it with so many requests, in such a way that the RAM will not be able to handle the messages that are coming. If you remember, we talked about or we mentioned in one of our class regard to buffer overflow. So buffer overflow, in the process, you have buffer overflow in the system, and that affects the system. And many times, the system could crash. So the best solution to this is to reboot the system. Threat actors also use the DNS stealth techniques described in the table to carry out their attacks. So the stealth techniques, fast flux. The fast flux, threat actors use these techniques to hide their phishing. I believe we all know what we mean by phishing by now. Okay, hide their phishing and malware delivery sites behind a quickly changing network of compromised DNS hosts. Okay, so what we mean in this case, like for instance, let's assume you have a website, or let's use the word domain, the domain name server. You have a domain name server. This is the address. Then after a while, it changes to a different address. Okay, and this change happens at a very fast rate. So even when you are trying to trace the actual site, you may not actually hit the site. You may get a different site. So all this, it means that the DNS has been compromised. So everything changes quickly. So the DNS IP address are continuously changed within minutes. So botnets often employ fast flux techniques to effectively hide malicious server from being detected. Okay, so the server that contain malicious programs are being hidden, which are owned by the threat actors. You don't want you to find those things. So you can see where so many things that threat actors could deploy just for the sake of hiding their tracks. Double IP flux. Threat actors use these techniques to rapidly change the host name to IP address mappings, and to also change the authoritative name server. This increases the difficulty of identifying the source of the attack. So when we say host name to IP address, the host name, the hosting company, let's say, when we say host name, like you could have something like, let's say, local.ns.com. That could be a host name. And the host name, instead of having a host name, local.ns.com, this host name is now changed to an IP address. So when next you are coming, instead of having local.ns.com, you now have 192.168 whatever. So this is what we mean by double IP flux. So this increase, and in fact, when next you go again, that local may not be there again. You have a different name. And the IP address again you hit again will change. So this is another way, another form of hiding, so that, to cover tracks so that the threat actors cannot be located. This increased the difficulty of identifying the source of the attack. Domain generation algorithm. Threat actors use the techniques in malware to randomly generate domain names that can be used as rendezvous points to their command and control servers. Command and control servers. So like this one is a technique that the domain names, like now we said looker.com. When next again you want to hit, instead of looker.com, you have james.com. When next again you hit, you have a different name. So many of these guys, they don't even use the .com. They use some form of extension that are not too common. And some of you must have experienced some of these things. Okay, so so these are what the threat actors will tend to do within this period by generating all these random domain names. So the DNS domain shadowing involves the threat actor gathering domain account credentials to silently create multiple subdomains to be used during attacks that typically point to malicious server without alerting actual owners of the parent domain. So I think I need to do a bit of demo here. Okay, let me see if I can. Oh. Okay, let me just take note of this so that when it comes to that time, I will see how I can just use that demo for all. Skills. Okay. Okay, we'll come to that. So what I'm just trying to explain here, I'm trying to. Okay, let me just put it this way. You have a website. When we say subdomain, www.luca.com is a domain name. Then when we now have Eric, you could have a site like eric.luca.com. eric.luca.com. That is a subdomain. Or you have mail.luca.com. That's a subdomain. So a threat actor could take advantage of subdomains to attack others. So your server can be infected with such attacking. So that is what we mean by this DNS domain shadowing. Okay. So the next one, DNS tunneling. DNS tunneling. Botnet use DNS protocol to spread malware or launch DDoS phishing attack. Security analysts must implement a solution to block outbound communication from the infected host to detect when an attacker is using DNS tunneling. DNS tunneling is another difficult way to identify an attacker. It's more, when we say tunneling, it's more of like encryption. An attacker uses encryption methods to hide the information as it transits over the network. So a DNS tunneling attack using TXT works like this. So when we say TXT is a file, okay, it works like this. The data is split into multiple encoded chunks. The data is split into multiple encoded chunks. So each chunk is placed into a lower level domain name label of DNS query. So we have different levels of domain name, okay? So a chunk is placed in a lower level of one of it, level of the domain name. So because there is no response from the local or network DNS for the query, the request is sent to the ISP recursive DNS server. Recursive DNS server. The recursive DNS server service will forward the query to the attacker authoritative name server. The process is repeated until all queries containing the chunks are sent. When the attacker authoritative name server receives the DNS queries from the affected device, it sends response for each DNS query, which contains the encapsulated encoded command. The malware on the compromised host recombines the chunks and executes the command hidden within. So what we mean is this method of tunneling, you have a data. The data is being broken into chunks, and these chunks are being sent, okay? They are not sent in group. They are sent independently. And when it reaches, so when it's being sent, there's this process of encapsulation. So the encapsulation is what I was talking about the encryption. It encapsulates the real information, the hidden information, and sent across. And the informations are usually infected, sent across. Then at the other end, everything is reassembled. So when you have a reassembled information, then that is where the attack is commenced. So that's what we mean by this DNS tunneling. So this is still a picture on the DNS tunneling. Please take note also, an infected system, a system or a server that is infected, which is used as command and control for an attacker, is referred to as bot, B-O-T, a bot, okay? So a command, so the attacker uses those systems as a command and control point to extend or to further attack other systems. So a filter, you have an attacker, then you have the command and control. These are all, so from here, the attacker uses the system to control all these bots. So a filter that inspects DNS traffic must be used to stop. Pay particular attention to DNS queries that are no longer than average. I mean, they are longer than average. What we mean by longer than average, there's a standard of queries that are being sent. A standard of queries. Okay, let's take, for instance, a size of, let's say, 64 bytes. 64 bytes. If it is more than 60, that, okay, is beyond the standard. So that are longer than average, or those that have is suspicious domain name. So already we are seeing, even from our WhatsApp, we are seeing some domain name. You see funny characters, and it ends, some of them will end maybe like XYZ, you know, things like that. Some of them can be malicious in nature. So DNS security solutions such as DNS tunneling traffic by identifying suspicious domain. So this is a device that Cisco want you to deploy if you want to handle DNS tunneling. So domain associated with dynamic DNS service should be considered highly suspect, please. So this is for DHCP. For DHCP, every system to be part of a network that's a system for it to be part of the network will need an IP address. It's just like you are having a home. You have a home in a location or in a street. If somebody wants to send a mail to that house or to your home, we need to know the street and we need to know the house number. So combining these two, that is how messages are being delivered to your doorstep. So every house needs to be numbered, and the number must be unique. No house within the same street should have the same number. Okay, so that is how it becomes so easier for a postman to identify your home within that street. So the same thing within the network. That is where the IP address is coming. So your system, for it to be part of the network, you need to have an identity, a number, that when a message is being easily be identified within that same network. Okay, and when even whoever that receives it will know. So you that you're sending, you become the source, becomes the destination, and vice versa. So that's what we need to understand. So there are two ways of giving out or giving a system IP address or giving it a house number. One of the way is to go into the system, enter the IP address by giving it the number, and the number has domain within that network, meaning that you need to understand subnetting and the IP addressing. I hope the video I shared to you must have explained this area. Then there's this other method again. When I say statically, you give IP address to the system. Then there's another method again that it has to be by another server within the network, is the one that will be dishing out the IP address to whoever that needs it or to whoever that is part of the network. Whoever that connects to the network and is configured to accept IP address automatically from the DNS server, the DNS server will now issue that IP address. So there's a process at which the computer system acquire these IP addresses from the DHCP server. Sorry, I said DNS, DHCP server. So this PC, the moment you connect it to the network, it undergoes some processes before it now finally gets the IP address. So looking at the diagram here, we have and mind you, any system that doesn't have an IP address cannot access the network, cannot access the internet. Every system needs to have this IP address. So there's a system here, which is the client, and there's a DHCP server on this side. So the client was added to the network. So when the client was added to the network, it generates a message, which we call it a DHCP discover broadcast. It sends a DHCP discover broadcast to within the network. It broadcasts the message. Everyone gets it. So it's only the DHCP server that gets this broadcast and now respond with what we refer to as what? DHCP offer. So the DHCP offer, which is done by the server, this time around, it's not going to broadcast it. It's going to send a unicast specifically to the guy asking for it, which we call DHCP offer. It sends it back. And in this process, while it's sending, it sends what? It sends the IP address that this client needs, assigns an IP address to this client, give it the subnet mask, the default gateway, and also gives the lease time. The lease time, that's the server is leasing the IP address to this very system for a period of 3 days. After 3 days, another IP, either the same IP address will be given or a new one will be given to the client. So when the client now receives it, okay, the client now sends what? A DHCP request. That's one of the message is sent. DHCP request, which is also a broadcast. Send it. Everyone gets it, including the server gets it. Then finally, the server now sends what? DHCP acknowledge message, which is also a unicast. So you can see the system here is always sending a broadcast, but the server is sending a unicast because the system doesn't know where the server or the DHCP server is. So that's why it's always sending a DHCP broadcast. So the final one, the DHCP server now send a unicast directly to the client, which is called the DHCP acknowledge. So let's look at what the threat actor will do with this kind of privileges. So DHCP attacks occur when a rogue DHCP server is connected to the network and provide false IP configuration parameters to legitimate clients, meaning that if you have a rogue a rogue DHCP server owned by a threat actor. Okay, it's a threat actor that will be responding to the client. So that's what we mean by that. So this server, that's a rogue server, can provide a variety of misleading information. It will provide wrong default gateway. The threat actor provides invalid gateway or the IP address of its host to create a man-in-the-middle attack. This may go entirely undetected as the intruder intercepts the data flow through the network. Wrong DNS server, threat actor provide an incorrect DNS server pointing the user to a malicious website. Wrong IP address, threat actor provides an invalid IP address, invalid default gateway address, or both. So the threat actor then creates DOS attack on DHCP client. Assume a threat actor has successfully connected a rogue DHCP server to a switch port on the same subnet as the target client. The goal of the rogue server is to provide clients with false IP configuration information. So you can see those who are within the network. For an attacker to do more of the damage, it means he must have access to the local area network directly, either by connecting his rogue device to a switch, yes, to a switch, then from the switch is connected to the internal network. So you can see, for this guy to achieve this, cannot do that outside the network. It has to be done within the network. So these are the steps in a DHCP spoofing attack. The step, you have step 1, client broadcast DHCP discovery message. 2, DHCP server respond with offers. Client accept rogue DHCP requests. Rogue DHCP acknowledges the request. So it's the same as the flow is the same as what we have here. Sorry. The flow is the same to what we have here. So that's what the attacker 2 will do. So there's a lab for you, exploring DNS traffic. I would love that you guys are able to look at this. Okay, so let's quickly go to this, and before I will now do a little bit of demo on what we have talked about so far. Enterprise services. Just to find out, are you guys with me?
Yes, we are, sir.
Yes, sir.
Okay, all right. So HTTP and HTTPS. HTTP and HTTPS, the common stages of a typical web attack are. Okay, first of all, we need to understand this hypertext transfer protocol, then hypertext transfer protocol secure shell. These two, you have some websites. There are some websites you go. When you look at the browser will show either a lock. Maybe you must have seen that. It will show a lock symbol, or it will show a message that this site is secured. Okay, so what it means is it is safe to enter your password on that site. It is safe to enter your password. That's when you have a lock or it shows secure. It is safe to enter your password. It is safe to enter your PIN on that site. Excuse me, let me. So, but when you have a site that shows just HTTP alone, HTTP, it means it is unsafe to use such a site. It is unsafe to use such a site. So let's look at the common stages of a typical web attacks. The victim unknowingly visits a web page that has been compromised by malware. Okay, so the compromised web page redirects the user, often through many compromised servers, to a site containing malicious code. When the user visits this site with malicious code, an exploit kit scans the software running on the victim's computer, including the OS, Java, or Flash player, looking for an exploit in the software. After identifying a vulnerable software package running on the victim's computer, the exploit kit contacts the exploit kit server to download code that can use the vulnerability to run malicious code on the victim's computer. After the victim's computer has been compromised, it connects to the malware server and downloads a payload, malware, or a file download service that downloads other malware. The final malware package is run on the victim computer. So this is just the process of how a typical web attack is done. So when you visit a malicious site, when we say malicious site, the site already contains uh, malicious kits or malicious codes that can easily be downloaded to your system via the browser. So it scans your system. That's when we say scan, exploit the system to find out if there are any vulnerability. Then in the process, the other stages are also will now take place, where the exploit kit also contact the server for further download of a malicious program to your system. So these are just the stages in terms of the process of this kind of attack. So let me see if I can connect to the other system so that I can just do a bit of demo. Okay, so while the system is booting, I want us to migrate to the next system because the one I'm using is a bit slow. So that's why I want us to migrate to the next system. But while it's booting, let's look at these other areas. Server connection logs can often reveal information about the type of scan or attack. Okay. The different types of connection status codes are listed here. Like when you open your browser, there are some, apart from browser, there are some other applications, especially those who are into web development. There are some kind of information you get either through your browser to show the kind of maybe like an error message or a message to signify something. So these are some of the message that will mean different things to the users. There's a message that you may
We can't hear you, sir.
Sir, we can't hear you again.
101 is an informational number. For each number, it has specific to the information. So this is okay. Let me. Come up now. All right. So let's switch to this very system. So do you have a new face?
Yes, sir.
Okay. So let me quickly switch also the audio to the new system. So can you hear me now?
We
Yes,
can
sir.
hear you, sir.
Okay, so I've switched to a different system so that I can do a bit of demo. So let's quickly move down to okay. So let's complete this one quickly, then let me begin to show you what we mean by this. So you have zero somewhere, maybe you come across it while you are dealing with web applications. This is what they mean. This is a provisional response consisting only the status line and optional headers. It is terminated by empty line. There are no required headers for this class of status code. Server must not send a 1xx response to an HTTP 1.0 client. All this is just talking about the version of the web client, except under the experimental conditions. Then when you have successful, maybe something that start from 2xx, maybe like 200 or 201, these are successful messages. So the client request was successfully received, understood, and accepted. Then when you have 300 or 301, it means redirection. What do we mean? Further action must be taken by the user agent to fulfill the request. A client should detect infinite redirection loops because these loops generate network traffic for each redirection. So what we mean, you are being taken to a different page or you are being taken to a different website. That's the redirection. Then when you now have this client error, that's when you have 400, 401 or 411 or thereabout. This means it's a client it's coming from your own end. You created that error. So this is for cases in which the client seems to have erred, except when responding to a head request. The server should include an entity containing an explanation of the situation. And if it is temporary, user agent should display any included entity to the user. So you could have, let me see if I can generate one. Let me see if I can visit a site. Okay, we'll come to this one. Let's see if we can visit a site. Sorry, I was going to. Sorry, okay. So let's go to a site. Let me see what sites can we. Let's see if we have Luca.com. Yeah, I think we should have this. .co. Let's say .n. Let's see if there's something that will come out of this. Okay, we're using Google. Google will not give us that. I'm trying to see if I can generate that error. One of this error. Okay, let me do this. Okay, I just created an error, but I'm trying to look for a place where it gives us those. Okay, maybe you may come across a site. You may come across a site, then not really a site, but you go to a page. Then on that page, you may have you may have an error message, and the error message you get will come with a number. You see, you have a number attached to it. Let me try this again. Let's say, let me see. I hope this one works. Let me try this. Google.com.
I can't hear you anything, please. I hope I'm not the only one.
Okay, how about now? Can you hear me? Hello?
Yes, I can hear you.
Yes, we can hear you, sir.
Yes.
We can hear you.
Okay.
We can hear you, sir. It should be her network.
Maybe
So,
it's our
madam, you
network.
can check your network again. It might be from your area. Check your network, please. So let me quickly share this. So let me try this. I hope you guys can see my screen now.
Yes, sir.
Okay, so let me go to this side. Let's go to google.com. Google.com. Let me type in something. Let's see if that exists. I hope you see what I'm typing. I hope you can see what I'm typing.
No, sir.
Check. Okay, but I believe you should have my
Yes,
browser.
I can see.
So I type google.com and I enter / and I put LUKSKSSDD. That's what
Yes,
I just did now. Then I'll enter. Let's see if we can get something here. Wow. It's like the network is a bit slow. Okay, let me see what I can do again. Okay. All right. It's giving me a message. Yeah, this is what I was looking for. This is what I was trying to get. So you can see on this side is giving us, I hope you can see what it just displayed now. Let me increase it. You can put your mic on mute, please. Is it Evelyn? You can put your mic on mute. So can you see this error?
Yes, sir.
Okay, so this error means something. There are some sites
Yes,
too,
sir.
you may
Yes,
get
sir.
a different error.
Yes, sir.
You will not have a number like this. Maybe you see 2002 something. They have different meanings. So that's what I'm trying to explain here. Based on our slide here, that's what I'm trying to explain. So you can see that error is coming from my own end because I entered the information incorrectly, and that is why I'm getting that reply. What did it say here? It said what? Google 404, that's an error. The request URL looks D was not found on this server. So it's coming from my own end. That's what we mean by that, a client. So you also have for that of server, if you run the server, there's a way from the server end, you should be able to see error messages like this. So all these mean different, they have meanings, but it relates to web applications mostly. So common HTTP. So let me also show you something again. When I was talking about the lock, let's go back to this browser again. So if you check, I was trying to go to a site, a different site that is probably not within Google, or maybe it's a page within Google, but that page is not there and it is not secure. You have this message. I hope you can see where my cursor is. You can see there's a place it says not secure.
Yes,
Hope you
sir.
can see that. Yeah, not secure. So it therefore means that at this level, we're using what? HTTP. HTTP. Let's see if we can confirm that. Let me copy this. I want to copy this message. Let me open a notepad. I want to open a notepad. I just copy. Let's see what we have. Okay, yeah. So if you check the notepad, I hope this is clear. Let me
do that on Microsoft Word so that I can increase the font size. So let me do that here. So I will increase it, increase the font size. So I want you guys to notice, if you notice, you see this is the address. You see http://. You see, that's the reason why it's showing it's not secured. But let me do another thing again. Let's go to Google, just Google site.com. Let me enter. So I'm going to the Google site now proper. So let me copy. So we're there. Let me copy the google.com and bring it here. So let me drop this here. So if you check the addresses, you check the two addresses, you can see the addresses, I believe there's a difference. The first one started with what? HTTP. The second one started with HTTPS. Okay, so when you're dealing with a site that has this, sorry, so let's look at, so that is it for the HTTPS I've mentioned earlier. Okay, the HTTP and the HTTPS. So when you have HTTP, that site is not secured. That site is not secure. But when you have HTTPS, the site is secure. But please take note, it doesn't mean that it's 100%. It's not 100%. Even there are ways threat actors have devised means to also use HTTPS too. Okay, so it's not that everything that you see HTTPS, it's 100% secured. No. So malicious iframe. Malicious iframes are often used by threat actors. It is a HTML element that allows the browser to load another web page from another source. Threat actors compromise a web server and modify web pages by adding HTML for malicious iframe. It can then be used to deliver a malicious exploit, such as spam, advertising, and exploit kits. So, like what we mean by iframe, who is into web design or web coding here? Is there anyone who is into web coding here? That's web development. Anyone? Hello? Can you guys hear me?
Yes, sir. You can.
Okay. So I just asked, is there anyone that is into web development? Or you don't understand what I'm asking? Do you understand what we mean by web development?
I understand, sir.
You understand?
Yes.
Yes, we understand.
Okay. You have any idea on what we mean by iframe? Maybe you can give us an idea. Maybe can you just say something, just a small hint on what is an iframe? Are you afraid? Okay. An iframe, okay, let me ask, an iframe is, have you ever experienced something like you go to a website? Let's assume it's Google website like this. You go to a website, then you now see maybe like a block. or a picture or a frame. It can be a frame attached to that website, but it's relating to a different website. It's not meant for the original website. Where can we get this? Where can we get this? Where can we get these sites? It's not really owned by that's like the Google, let's say this Google site. It's not really owned by them, but you just see another kind of, maybe like advertisement. Yes, those ones are common. You just see like advertisement. Let me see if I can get from this guy. Let me try a YouTube, whether I can get it from there. I'm trying to see if I can just like try to download a YouTube video. Well, anytime I'm streaming, this is really slow. This is really slow. So let me try here. Let me see if I can get it here. This one. Please, don't worry. I'm just trying to see how we can get that. Why is it? This is really slow. It's not giving me what I need. Site is still dragging. But just like, okay, like this is YouTube. This is YouTube. What do you have here? But okay, it's taking me to the site. Okay, this one is still not giving me what I want. It's still not giving me what I want. Anyway, there are some sites when you go to, like, let's say like this site, you now see like an advertisement, another advertisement. So those can be an iframe, or like this one, this very one is owned by YouTube. This one is owned by YouTube. Trying to pause this. Like this, where you have this chat area. This is a frame. I mean, this, yeah, is a card that is allowing this chat area. You see messages here. But this is owned by YouTube. They designed this, they added this. But iframe tend to look like this, but it's owned by, though there are two types, there is one that the owner of the site will allow the iframe within its own site. Then there are others again that attackers or hijackers will add the iframe to it, such that when you click, it may take you to one advertising site or malicious website. So some of you must have come across such. So that's what I mean by iframe. So let's go back. I hope with a little explanation you're able to understand that. So you have malicious iframes. It can take you to sites that contain a lot of malicious programs that can be downloaded to your site. Even the one I just did with that YouTube contain malicious scripts that can easily be downloaded to my system. But what I've done, I'm able to put some anti-malware tools to help me, or to help protect me. So HTTP 302 cautioning, threat actors attack by using the 302 found HTTP response status code to redirect the user web browser to a new location. The browser believes that the new location is the URL provided in the header, and it's invited to request this new URL. This redirect function can be used multiple times until the browser finally lands on the page that contains exploit. The redirect may be difficult to detect since the legitimate redirect frequently occur on the network. So if you remember, I said you can see the 3SX means what? Redirection. So with this, it means the attacker could redirect you to malicious sites. Redirect you to malicious sites where they could easily download codes to your system. So we've mentioned the domain shadowing. I hope, okay. So today we'll stop by 9:30. So let me quickly conclude this part. Domain shadowing. To attack, the threat actors must first compromise a domain, then create multiple subdomains of that domain. So when we say subdomain, this is a subdomain I was trying to explain earlier. This is unijust, unijust.edu.ng. This is our website. Okay, it's not connecting. The site is down. Let's see. Let's say Google. This is google.com. This is google.com, Google websites. Okay. Then you have also, you can have mail.google.com. Let me use this on a different browser. Let me repeat that. Google.com. This opens this. Then you can have mail. You can have mail.google.com. This is mail.google.com. So this is a subdomain. This is a subdomain of, that's what we're talking about. This is a subdomain, and it takes us here. It's redirecting us to this page. So it's a subdomain, okay? So let's go back. So attackers could also hijack subdomain. So that's what we mean by this. Email, as the level of email use rises, security becomes a greater priority. Today, HTML messages are accessed from many different devices that are often not protected by company firewall. HTML allows more attacks because of the amount of access they can sometimes bypass different security layers. The following are examples of email threats. You have attachment-based attacks, where emails are being attached. Threat actors embed malicious content in business files, such as an email from the IT department. Email spoofing. Threat actors create email messages with forged sender address that is meant to fool the recipient. Spam. We've talked about spam. Open mail relay server. Threat actors take advantage of enterprise servers that are misconfigured as open mail relays to send large volumes of spam or malware to unsuspecting users. Then homoglyphs. Threat actors can use text characters that are very similar or even identical to legitimate text character. So what we mean, like here, maybe you have you can have character like this. Maybe you have something like this. Maybe instead of let's say Google, we know that this is google.com, but you could have something like this. Okay, so characters could be changed like this. So instead of having you have a 0. So that's what we mean. So there are so many ways that threat actors could deploy or use. So this is just about the email. Then database, we've talked about code injection, SQL injection. We also mentioned cross-site scripting. We've mentioned that in one of our classes. Two main types of cross-site scripting. We have the stored, reflected. So the stored is, when we say the stored, okay, first of all, let's look at the cross-site scripting. Occurs when web pages that are executed on the client side within their own browser are injected with malicious script. When we say client side, the pages are loaded from your site. The way the script works is send information to your system. So it's your system that will complete the process of opening the page. Your own laptop or whatever completes the process of opening the page. So in that, script can be attached and sent over to your browser, and the browser complete the process of opening that page. So in that process, malicious scripts can also be injected where your browser opens it. So two main types of cross-site scripting. Stored persistent. This is permanently stored on the infected server and is received by all visitors to the infected page. So the scripting is already stored on the server, so whoever that visit that site will be infected. Reflected, non-persistent. This only requires that the malicious script is in a link, and visitors must click infected link to become infected. So you can have a link, maybe a link that takes you to a different site, or that maybe say, okay, you should download or just click to get an offer. In the process, you click, everything is being downloaded to your system. So let me quickly explain this. Virtual machine. This is a lab that you need to do. You need to have a system that is good and can handle the virtual machine. I've mentioned that before. So the virtual machine, because we're beginning to go into a process of analysis where you need to install the virtual machine so that you can run some analysis to detect malicious program, or to also see the behavior of some malicious program. So I've mentioned in one of our class that you need to go to a website called the VirtualBox to download the virtual machine software. And this is my own virtual machine, which I've already installed. And I'm able to install another operating system, which is Ubuntu 2022. I also installed Windows operating system, then also Windows 10. So maybe what I need to do is to install a tool that we can use in the class, but when you go through the lab, they will guide you on how you can download one of the tools that you can install within the VirtualBox. So this is my own VirtualBox for this system. So this lab guides you on how you can install the VirtualBox. So when you install the VirtualBox, I think there's a place that you're going to use this. You see, in this place, you begin to learn how to inject, that's to begin an attack on a database using the SQL injection. So it would be nice you have this. Okay, even this is another lab for server logs to look at some logs. You know, when we say logs, everything that happens within the server, every activity that happens, the server tries to keep logs of those activities. So the activities can be, one of the activities can also be an attack or a threat. So maybe somebody makes an attempt to do some certain things within that. Servers could keep information regarding those attempts. And also server can keep information with respect to if there are errors on the server, it keeps information in the log files. So mitigating common attacks, we'll soon conclude this. Mitigating common attacks. Defending the network. Constant vigilance and ongoing education are required to defend your network against attacks. The best practice for securing a network is develop a written security policy for the company, educate employees about the risks of social engineering, and develop strategies to validate identities over the phone, via email, and so on. Control physical access to systems, use strong password and change them often. Encrypt and password protect sensitive data, implement security. All these are just a way of defending your network. This one is how to mitigate malware. You can introduce what? Antivirus software. Then you also prevent malware files from entering the network. So in this case, security devices at the network perimeter can identify and remove known malware files based on their indicators of compromise. So like some of these Cisco devices can also help in doing that. Okay, so this is also part of the mitigating worms, and we are told that worms are alive when the network is up. Okay, worms are more network based than virus. So worm mitigate requires diligence and coordination on the part of network security professionals. So this is just a figure to the response of worm attack that can be broken down into 4 phases: the containment, the inoculation, quarantine, and treatment. So this is the way to mitigate that. So this explains the phases on how to mitigate worms on the network. Then reconnaissance attack. Reconnaissance are typically a precursor to other attacks that have the intent of gaining unauthorized access to a network or disrupt network functionality. So a variety of technologies and devices can be used to monitor this type of activity and generate an alarm. So Cisco ESA provide intrusion prevention in the standalone device. Additionally, enterprise routers such as Cisco Integrated Service Router, ISR. So these are some devices to prevent any reconnaissance attack. So deploying this on the network will also help in this type of attack. Okay. So always use strong password. You need to know, how do you know your password is strong? There are some sites you can visit to know which password is strong. Like the best way to even enter a password is to use a phrase. Maybe you can use words like "I am good," but don't use common name, don't use dictionary names. Okay. So disable account after a specific number of unsuccessful logins has occurred. So all these are just to mitigate against access attack. So when I talk about the password, strong password or weak password, you can also check on this site. There are some sites that could help you, or you just search for, let's see, this. Let me try this. My password strong. Okay, I just type is my password strong. Okay, let's look at this site. How secure is my password? This is a site. You can take note of this site. How secure is my password? You want to know how strong your password is. So let me enter Looker. Let me see. Please note this tool is now being maintained over security. Okay, they've changed the site. It's no longer on this site. So it means they've changed the site. So it's these guys that have handled it. Security.org handle this. So let me enter a password. Let's say Luca. I've entered Luca. See what happened. The moment you type, everything changed color. So I've entered Luca. So if you come down, you see it will take a computer about 100 microseconds to crack your password. So let me enter David. It takes 9 milliseconds to crack. So let me enter IT, put a space, essentials. Let me start again. IT in capital, put a space. I'll put essentials. Okay. So this one is going to take 900,000 years to crack this. So what if I put IT again, IT essentials. So instead of a space, I put an @ sign. Then I put the essentials. So it's going to take 400,000 years to crack this. So what if I use this? I love, with a space, I love, I put another space, IT essentials class. So you can see how long this will take to crack. So this takes about 676 non-million years. I hope the pronunciation is correct. So I hope you guys are with me. So that's just for password. And you need to disable accounts. So mitigating attacks. Okay, this one is still on mitigating attacks. So you guys, you need to look at this. Mitigating DOS attack and so on. So I'll stop here. And I want you guys to, I will send what you need to do as another assignment or homework before we meet tomorrow. So any questions so far? I've been talking. Okay, the last thing, I think I need to show you this before I give you room for the question. Hope you can see the screen. Hope you see what I'm doing. Hope you can see what I'm doing. Hello,
Yes,
everyone.
sir.
Oh,
Yes,
okay.
sir.
So, all right. So my system is connected to a wireless network. I want to explain about I just want to demonstrate with respect to the app cache. Okay, so this is I'm connected to a wireless network. This is a wireless network. So I'm going to use this command ipconfig/all to know my MAC address and IP address my system the IP address that is already been given to my system. So looking at this is my IP address that has been given to my system. It ends with 61. This is my physical address of the network interface. And it shows that I'm using wireless here. So what I'm going to do, let me open another command line interface. So I'm going to type this time around app. You put a space and you put A. Enter. So you can see I'm getting some funny addresses. So let's look from here. Let's see the one we are interested in. So all these are the app cache. These are the app cache of my system. The one we look at is the interface. If we look at the interface, my interface for this, the wireless, the IP address is what? You can see the IP address here is 61. So we want to look at that interface. Let's see what is there. Okay, this is it. So let's look at that interface. So this should be it, this site. This is the interface. Okay, that's 192.168.71.61. So let's look at the cache, the MAC cache. So this is the cache. So it therefore means that, like what I have here, you can see it's saying dynamic. So my system is connecting to another system, and the system is this MAC address. That's my system is sending a message to another system, which is my phone. Actually, is my phone. So it's hitting my phone, and this is the MAC address it's able to get. So when we compare this address with the one I have on my system, I doubt if it will be the same. If you check here where you have physical address, so let's compare that. Let's see if they are the same. So you can see here we're having 4A, that's A4 here. That's for this, we're having this. On this side, we're having this. So it therefore means that the device that is serving as my gateway is here. It's 192.168.71.166 and is connected to this, which is dynamic. This very one is meant for broadcasts. You know, when you are broadcasting in the broadcast network, it reserves a particular IP address for broadcast, including the MAC address. The MAC address here is written FFF all through. So these ones are usually used for broadcasting, to broadcast the message. Then these very ones, you ignore, these very ones are not for this class, okay? Not for this, is beyond this class, these very ones, okay? So, but the ones you should look at are usually this and this one, that's all. So I'll stop here. Any question from the class? Is this program becoming difficult for you guys? Hello?
Yes, sir.
Is it